So okay, for this video we're going to solve some examples related to electricity. So for example number 1, we have the current in a conductor is equal to 3 amperes. Determine the number of electrons flowing in the conductor for a time of 3 seconds. So in here we have a conductor in which the current that flows through it is at 3 amperes. So you want to determine how many electrons are there that would produce this current for 3 seconds. So in our solution, we'll be applying the first definition of current, which is that it is the flow rate of the charges. So in that case, I now is equal to Q divided by T. So we're given here our current. We're also given the time, so it's just direct substitution. So the Q now can be computed simply as I times T. Thus, the total charge flowing in 3 seconds is equivalent to 9 coulombs. Or as we can see, coulombs now is the same as, so coulombs is the same as ampere seconds. Okay, so later on, if you have problems where in the unit of a number or if a value is ampere seconds, it also means as coulombs. Okay, so in this case, so 9 coulombs is not our final answer yet, since ang hinahanap natin is the number of electrons. So we have defined already from electrostatics that the total charge can be computed as the number of electrons flowing times the charge of that electron. So Q now is computed as N times Q, or the Q of electrons. So Q, E is a constant value. So we have solved for our total charge. So substituting now our value, 9 coulombs is equal to N times the charge of electron, which is 1.6 times 10 raised to negative 19 coulombs. So in here, we'll now be able to solve for the number of electrons flowing for a time of 3 seconds as equal now to 5.625 times 10 raised to 19 electrons. Okay, so for the next problem, we have in relation to example number 1, if the conductor now in the first example has a diameter of 5 millimeters and length of 2 meters, determine the drift velocity of the electrons and the free electron density of the given conductor using the given time 3 seconds. Okay, so we have defined also the equation for current with relation to the drift velocity. So I here is now equal to Qn AV, okay, which is equal to 3 amperes. So we are not given. So if we're going to check our equation, so yes, we know the current, okay. We know that Q is constant. We do not know our electron density. We can solve for the area or the cross-sectional area given the diameter, but we do not know our drift velocity. So how are we going to use this equation? So we cannot use this one, but we know the time of travel of our electrons, and we know how long our electrons would travel throughout our conductor since we're given the length of the material. So in this case, we could solve first for our drift velocity using our motion equation, which is now equal to length divided by time. So we're given the length, we're also given the time, so we could simply solve for the drift velocity as the length traveled divided by the time traveled by the electrons. So in this case, 2 divided by 3 is now equal to 0.667 meters per second. So that is the drift velocity of your electrons for the given conductor. And now we have solved for the velocity or the drift velocity. We can now solve for our electron density. So we could now use the equation here. So substituting now our values, we can now solve for our N, But before that, we solve first for your area, which is pi d squared over 4, giving us this value. So all of the values now are present, so we can now solve for n as 1.432 times 10 raised to 24 electrons per cubic meters. Okay? So, saan to nakuha? Nakuha to dito sa equation na to. Okay? So, let's move to the next example. Okay, still related to example number 1. We have example number 1.c. So, what is now the current density of the conductor in the previous problems? And if a power source of 12 volts is supplied to the conductor, how much will be the resistance? So in this problem, we're now going to apply the third and the fourth definitions of current, in which for the first question, it will be the current density. And as we have discussed, current density is equal to the current divided by the area of our conductor. So from problem 1, we were given our current, and from problem 2, we have solved already for the cross-sectional area of the conductor. So in this sense, just substitute the values of I and of A. So we'll have 3 divided by the area 1.963 times 10 raised to negative 5. Or the current density now of our conductor is equivalent to 152,827.30 amperes per square meters. While for the second question, we want to determine the resistance given a power source of 12 volts. So in here, we're going to apply now our Ohm's law, which is given by the equation V is equal to IR. So we're given the voltage, 12 volts, and we're also given the current, which is 3 amperes. So therefore, our resistance now is equivalent to 4 ohms. Okay? So next, we have example number 2. So we are given a 25-meter long steel wire at 20 degrees has a radius of 0.20 millimeters. Determine the resistance of the wire if it is heated to 35 degrees Celsius. We are given the temperature coefficient and the resistivity at 0.0038 and 1.59 times 10 raised to negative 8 ohm meter. So in here, we're going to apply now our resistance and the resistivity. So as we have discussed, the equations now for resistance and resistivity, and we have different equations. So dito, gusto kong malaman the resistance of the wire or of our conductor from 20 degrees to 35 degrees. So in that case, for 35 degrees, I need to solve for, or I can use the equation. We need the equation R is equal to rho L over A. So we know your length, we also know, or we could also compute for your area. But the given values are for the 20, it's given for the 20 degree Celsius na condition ng wire. So ang kailangan ko dito is the 35 condition or the rho at 35 degree condition. So we cannot use this equation first. So what will I do? What I can do is to solve first for the resistance using the condition of 20 degrees Celsius. So in that case, for solution now, I will use the equation, this equation, but in terms of the 20 degree condition. So we're given the rho at 20, okay? So which is 1.59 times 10 raised to negative 8 ohm meter. So we multiply it to the length, which is 25, and the area, which is 3.14 times 10 raised to negative 8. So please do not ask me anymore how did I get this. Okay, so you're given a radius, so meaning the area is a circle, so you can compute for the area directly. Okay, so with this, we now have our resistance at 20 degrees, which is 12.65 ohms. Okay, so since we're given already our R20, we could now use the second equation, which is R35 equal to R20 plus or times 1 plus alpha times T35 minus T20. Okay, so hindi ko na kailangang isolve yung ating rho 35 kasi pwede ko na siyang masolve agad in this equation. Okay, so substituting our values, we'll get now a resistance for the 35 degrees Celsius at 13.37 ohms. So as you can see, the higher the temperature of a conductor of a material, the resistance would also increase. Okay? Okay, so in relation to example number 2, let us solve another example. So if the wire now in the previous problem supplied by 25-volt potential throughout the change in its temperature, determine the values of current at each temperature. So for this problem, we'll only be applying our Ohm's law, which is V equal to IR. So in this case, the current now will also change when our resistance changes. So in that matter, so at a temperature of 20 degrees Celsius now, so we have our resistance computed at 20, which is equal now to 12.65. So computing now for the current of our system or of our circuit at 20 degrees, the current is computed as 1.98 amperes. And that for the temperature at 35 degrees, we have computed that the current or the resistance at 35 is 13.37. So computing now, the current for 35 degrees is equal to 1.87 amperes. So as you have noticed, when our temperature increases, resistance increases, but the current now decreases. So ibig nyo sabihin, pag mas mataas ang resistance, mas napipigilan niya ngayon yung flow ng current, kaya mas maliit yung value ng currents ninyo pag mataas ang resistance. Okay? So let's solve another example, still related to the previous problem. So, what now will be the temperature of the wire if it has a resistance of 12 ohms? Also, what is the conductivity of the wire at this temperature? So, in here, our solution now will follow the equation R2 equal to R20 plus alpha times T2 minus 20, since we have a change in temperature, which is from 20 to a temperature that causes a 12 ohm resistance. So we are given already. So bakit 20 ang ginamit ko instead the 35? Kasi ang given sa atin is the alpha of 20 degrees Celsius. So substituting all the values, so we have here 12 ohms, the resistance at 20 degrees, and the alpha at 20 degrees. Will now be able to solve for the temperature, which is 6.478 degree Celsius. Okay? So, tama ba? Mas mababang temperature, mas mababang resistance. Okay? And then, for the next question, we want to solve for the conductivity. As we have computed or we have discussed, the conductivity of a conductor of a material is equal to the reciprocal of the resistivity. We do not know the resistivity of the material at 12 ohms or at 6.478 degrees Celsius. So therefore, we have to solve first for rho of 6.478 degrees. And to solve this, we'll also use the same equation. Ang pagkakaiba lang is instead of using your resistance, we'll be using your resistivities. Okay? So that will now be rho at the second temperature, 6.478, is equal to the rho given 20 degrees is multiplied to 1 plus alpha times the temperature of the resistance at 12.65 minus the temperature at the 12 ohm resistance. So, we all have our values required to solve for the rho at temperature 6.478 degrees. So, we just substitute our values in the equation. So, the rho 20 is given at 1.59 times 10 raised to negative 8. We have our alpha at 0.0038. The temperature at 12.65 is 20 degrees, and the temperature at 12 ohms is 6.478. So, computing now will arrive at a resistance or a resistivity at a temperature 6.478 degrees Celsius, which is equal to 1.672 times 10 raised to negative 8 ohm meter. Okay? So, hindi pa ito yung ating final answer because, as we have said, our rho is equal to the reciprocal of the conductivity. And what we are solving is the conductivity of the wire. So, take now the reciprocal of this value, the conductivity, at 12 ohms is equal to 5.982 times 10 raised to 7 per ohm meter. Okay? So, let's have the next example, number 3. A circuit has an EMF of 20 volts and is connected to a 2 ohm external resistance. Determine the internal resistance if a current of 2 amperes flows through the circuit. Okay, so in this problem, we do not know if it is charging or discharging. So, in that matter, we'll assume that it is a charging EMF. So, we'll use now the equation E is equal to I times R plus R. So, charging or discharging is plus. Okay? So, it means it's moving from negative to positive. So, substituting now, we have your EMF, 20 volts. We're given the flow of current, which is 2 amperes, and an external resistance, which is 2 ohms. So, with that, we'll now be able to compute for R. And we have computed a positive value of the internal resistance, which is 8 ohms. In that matter, tama yung assumption natin that it was discharging. Okay? So, kung nag-negative man yung sagot nyo, palitan nyo lang ito. Dapat minus. Yun lang yung ibig niyang sabihin pag nag-negative yung answer ninyo. So, let's solve example number 4. A charging circuit has an EMF of 25 volts with internal resistance of 2 ohms. An external resistance is connected. Determine the current flowing in the circuit and the value of the external resistance. The voltage across the external resistance is given at 30 volts. So if the same circuit is to be discharged with the same value of current, what should be our EMF? So, in this case, we are given that it is charging. So our equation now will be equal to I times R minus R. So we're given your EMF. We do not know your I. We do not also know our external resistance. So how are we going to solve for this problem? So what we will do is to first simplify our equation. So I times external is also equal to your voltage. So we are given from the problem that the voltage on our external resistance is 30 volts. So with that, we could compute now or substitute the values. The EMF, 25 volts, minus the voltage on the external, 30, minus your current, I, times the internal resistance, 2 ohms. So if we're going to compute, R now is equal, or I, the current, is equal to 2.5 amperes. Okay? So, for that, we'll now be able to compute for our external resistance using Ohm's law. So, 30 volts is equal to I, 2.5 times the resistance. So, the external resistance now is equal to 12 ohms. And then, the next question, if we have the same circuit, but it will be discharging, what will now be the value of your current? So, pag discharging, magiging plus na yon. So, we'll have the same values. Ang magbabago lang will be our current. So that will now be 30. Or magbabago na yung ating EMF pag discharging na siya. So 30 volts plus the computed current times the internal resistance. So the EMF now when it is discharging will be equal to 35 volts. Okay? So that's for example number 4. So next, example number 5. We have 3 resistors connected in series. Determine the total current and the resistance and all other unknown values. So we are given here our circuit. So R1, R2 are all connected in series as they only have one common node for each connection. So R1, R2 have only one common node. R2 and R3 only have one common node. So for this case, all unknowns will be our total resistance and your total current, the resistance of 2, the currents passing I1 and I3, and then we also have the voltages across the 3 resistors, V1, V2, and V3. So for our solution, we can identify first our current. Since it's in connection or it's in series connection, we know that the individual currents is equal to the total current. And we are given here the value of one of the currents along or through our R2, which is 2 amperes. Therefore, our I total, our I1, and our I3 is also equal to 2 amperes. Okay? So, for our requireds, we have solved already I total, I1, and I3. So, next, applying now our Ohm's law for total voltage, since we already know your I total and we're given your total voltage, we can now solve for the total resistance, which is simply the sum of the individual resistances. Or, since hindi ko alam si R2, we could simply use our total values. So, 20 volts, your total voltage, and our total current, 2A. So, our total now is equal to 10 ohms. So, next, with that, we know that the total resistance is equal to, so before that, so check lang natin, we have computed already for our total. So, for R2, since we know that the total resistance is equal to the sum of the individual resistances for series connection, so masosolve ko si R2 simply as 10 equal to 2 plus R2 plus 3. Or R2 now is equal to 5 ohms. Okay? So, with that, we can now solve for our voltages individual using Ohm's law. So, we'll have V1 is equal to I1 times R1. So, I1 times R1, voltage now is equal to 4 volts. And then, for V2, that will now be equal to I2 times R2, which is 5. So, we'll have here 10 volts. And lastly, for V3, that will now be 2 times 3, which is equal to 6 volts. So, if we're going to check the sum of the 3 voltages, 4 plus 10 plus 6 is equal to 20 volts, which is really equal to your total voltage. Okay, let's solve the next example. So we have example number 6. So we have 3 resistors connected in parallel as shown. We now determine the total current and the total resistance and all other unknown values for the circuit. So this is our diagram of the circuit. So we have R1, R2, R3 connected in parallel. So makita natin R1 and R2 are joined at this point and this point. So they have two common points. Then R2 and R3 are connected at this point and this point. So they share two common nodes. So they are in parallel. Pero kung isa lang yan, it is in series. Okay? So for our unknown values, we have R total, I total, our R2, I3, I1, and the individual voltages. So since this is in parallel connection, we know that the voltages across your individual resistors are equal to each other and that it is equal to the total voltage. So therefore, V1, V2, V3 is equal to 20 volts. So let's check already. We have computed for our V1, V2, and V3. Okay? So with that, we now can compute for the next unknown. So ano ang pwede kong ma-solve dito? So we're given the total voltage, pero hindi ko pa alam ang ating total resistance at ang ating total current. So we cannot solve either. Okay? So ang mangyayari, we'll apply now your Vn and or your Ohm's law, which is V equal to I times R. So i-compute muna natin yung mga unknowns for each resistors. So for resistance 1, this can now be, or resistor 1, that will now be V1 equal to I1 times R2. Since given na tayo ng V1, given na din tayo ng R1, we can now solve for I1, which is equal to 10 amperes. Okay? So next, we have V2, which is also 20 volts. And that's equal to I2 times R2. Ang given sa atin is I. So masusolve ko ngayon ang ating R2, which is now equal to 10 ohms. And lastly, for V3, which is also 20 volts, is equal now to the given resistance 4 ohms times the unknown I3, which is now equal to 5 amperes. So in that sense, we have solved already I1, R2, and I3. So for parallel connections, we know that the total current is equal to the sum of the individual currents. We all have our currents already. So I total now is equal to I1 plus I2 plus I3, or that is now equal to 10 plus 2 plus 5, which is equal to 17 amperes. And computing now for our total resistance, we could compute it by the reciprocal of the sum of your 1 over R. So we'll have 1 over RT is equal to 1 over R1, which is 2, plus 1 over R2, which is equal to 10, plus 1 divided by 4, which is the resistance of R3. So computing RT now, that is equal to 1.18 amperes. Or we could simply just use our Ohm's law. V total is equal to I total times RT. We know total voltage is 20 volts. Computed IT is 17. So you can solve for RT, and it should also be equal to 1.18. So that's 20 divided by 17, giving us a value of 1.176 ohms, which is almost equal to this one. Okay? So we have example number 7. We have 5 resistors connected as shown. Determine now the total current and the total resistance and all other unknowns. So, as you can see from the figure, we have now a combination of series and parallel connections. So, for this problem, we are given the following values. We have R2, R3, and R4. We also have the currents for resistor 1 and resistor 5. And we have our total voltage, which is 30 volts. So before we could start with our solution, we have to first identify which of the following resistors are connected in series and which of the following are connected in parallel. So from our figure, we can see that the resistors 1 and resistors 4 are connected in series. And also, from the figure, we could see that R2 and R5 are also connected in series. And that the connection of R2 and R5, when we combine it, will now be in parallel with R3. And once we have combined R2 and R5 and R3, it will now be in series with the combination of R4 and R1. Okay, so in that case, we have identified that R4 and R1 are in series, and in series connection, we know that the current for the resistors will be equal for each resistors. So we are given now I1, which is 4 amperes. Therefore, the current of resistance 4 should also be equal to 4 amperes. Okay, so let's fill up our table. Also, since R2 is in series with R5, therefore, the current passing through the two resistors will be equal. We are given I5, so therefore, I2 is now equal to 1 ampere. Okay, so next, we can see that the resistance and the current for resistor 2 is already given. So we can solve now for the voltage across resistance 2 using Ohm's law. With that, we'll have now 2 times 1 is now equal to a voltage equal to 2 volts. And then, same goes, R4 and I4 are given. So therefore, we could solve for V4 as I4 times V4, and it will give us a value of 16 volts. Okay? So, next, we know that if R2 and R5 and R3 are combined, so we'll have now a circuit that will look like this one. So this will now be our new circuit. So this is R4, R1, and this is the combination of 2, 3, and 5. So R4 and I1 and R1 is 4 amperes. Okay, so it's in series to this one. So this is also 4 amperes, combination of 2, 3, and 5. So it will also be the same current that would pass through our source. Therefore, our total current is also equal to that current passing through I1 and I4, which is equal now to 4 amperes. Okay? And if we're going to look at our table, V total is given, I total is given, so we could also compute for our total resistance by Ohm's law. So with that, our total now is simply equal to V total divided by I total. So our total now is equal to 30 divided by 4, which is now equal to 7.5. Okay? So also, if we're going to check, our I total now, which is 4 amperes, will be equal to the combination of R3 and I2 and I5. Okay? So, di ba? Combination ng R2, R5 at R3 is equal to 4. Pero since parallel ito, our 4 amperes now is equal to I3 plus I2 or I5. So in that case, we'll now have I total is equal to I5 plus I3 equal to 4 amperes. And we know already I5, which is 1, so therefore we could compute for I3, and that will now be equal to 3 amperes. So let's fill up our table. I3 now is equal to 3 amperes. So again, looking at our table, we have now R3 and I3. Thus, we could compute for V3 as 3 times 3. Therefore, V3 now is equal to 9 volts. Okay? So, let's fill up our table. We have 9 volts. Okay? So, let's continue. We still have 1, 2, 3, 4 unknowns. So, let's continue to the next slide. So, let's continue our solution. So, as we have said, or as we have identified, R2 and R5 are in series. So therefore, their voltages now, or the corresponding voltage of V2 and or R2 and R5 will be equal to the sum of their individual voltages. Okay? And that for R2 and R5, yung combination nila, it will now be, the combination of their voltages will be equal to the voltage of R3. So therefore, we could write that V2 plus V5 is equal to V3. So if we're going to check from our table, we are given already your V2 and we're also given your V3. So we could now compute for V5 as equal to 7 volts. Okay, so let's put that on the table. So with that, we're given now V5 and I5. So by Ohm's law, we could compute it as I5 times R5 is equal to V5. So R5 now will be equal to 7 ohms. So let's put that on the table as well. Okay. Last, we have your R1 and V1. So how are we going to solve for this value? So for V1, okay, we already know that the total voltage is 30 volts and that will now be equivalent to the combination of, so the total voltage will be equal to the voltage of 4, voltage of 1, and the combination of R2, R5, and R3. So bago natin makuha yung R1, I have to first identify what is now the voltage of R2, R5, and R3. So since parallel sila, okay, so pag pinag-combine ko, the voltage of R2, R3, and R5 is also equal to the voltage of 3, which is now equal to 9. Or the total voltage now is equal to V1 plus V4 plus voltage 3, or that's V2 plus V1, or V2 plus V5. So substituting now our value, that will now be 30 minus V1, or 30 minus V4 minus V3. And that will give us a value of 5 volts. Okay? So with that, we can now solve for R1, which is equal now to I1 times R1 equal to V1. So computing for R1 now, that will give us a value of 1.25 ohms. Okay, so that's for R1. Okay, so for your R total, Another way to solve for this is by R1 plus R4 plus R3 and the combination of 2 and 5. So for 2 to 5, the combination of the resistance is 9. Okay, so compute for the total resistance or equivalent resistance of 2, 3, and 5. So that will be 1 over 9 plus 1 over 3. So R235 is 225. So pag i-check natin yung ating resistance, so dapat equal siya sa summation ng R1, which is 1.25, plus R4, which is 4, plus the equivalent resistance of 235, which is 2.25. So, dapat 7.5 din yung ating makukuha. Okay? So, this is another way to solve for your total resistance. Okay? So, total resistance or total is equal to R1 plus R4 plus this value. Okay? So, that's it for example number 7. Okay, that's all for our sample problems on electricity. Thank you for listening. So, for more problem examples, you can always check on your modules.